Hello everyone. Welcome back to my channel. Last time we used inequalities to make comparisons in one triangle. This time, we will apply the Hinge theorem and its converse to make comparisons in two triangles. Before that, let us have a short review of what we discussed last week. Number 1. Is it possible to form a triangle with side lengths 4, 6, and 10? Answer: no, because adding 4 and 6 the answer is not greater than 10. Number 2. Is it possible to form a triangle with side lengths 3, 11, and 7? Answer: no, because adding 3 and 7 the answer is not greater than 11. Number 3. Is it possible to form a triangle with side lengths 3.3, 4.1, and 5.4? Answer: yes, because it satisfies all the conditions to form a triangle. Number 4. Find the range for the measure of the third side of a triangle if two sides measure 15 and 43. Answer: letter B. By angle-side relationship theorem, the range of the length of the third side is between 28 and 58. Number 5. Find the range for the measure of the third side of a triangle if two sides measure 17 and 33. Answer: letter C. By angle-side relationship theorem, the range of the length of the third side is between 16 and 50. Number 6. Write an inequality to describe the length of MN. Answer: letter B. By angle-side relationship theorem, the range of the length of the third side is between 5 and 19. Number 7. Using the figure, what is the value of x? Answer: letter C. By applying exterior angle theorem, the value of x is 13. Now, let's proceed to the first theorem in inequalities in two triangles, the Hinge theorem. It states that, if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Figure 1 shows that, the two sides of triangle ABC are congruent to two sides of triangle DEF, and the included angle of triangle ABC is larger than the included angle of triangle DEF. Such that, AB is congruent to DE because they have the same tick marks, BC is congruent to EF because they also have similar tick marks, and measure of angle B is greater than measure of angle E. By Hinge theorem, if measure of angle B is greater than measure of angle E, then side AC is longer or greater than side DF. Let's have this first example. Write an inequality relating the lengths of CD and AD. In triangle ABD and triangle CBD, AB is congruent to CB, BD is congruent to BD, and measure of angle CBD is greater than measure of angle ABD. By the Hinge theorem, side CD is greater than side AD. Second example, compare the measures of AD and BD. In triangle ACD and triangle BCD, AC is congruent to BC, CD is congruent to CD, and measure of angle ACD is greater than measure of angle BCD. By the Hinge theorem, if measure of angle ACD is greater than measure of angle BCD, then side AD is greater than side BD. Third example, answer the given problem. Doctors use a straight leg raising test to determine the amount of pain felt in a person's back. The patient lies flat on the examining table, and the doctor raises each leg until the patient experiences pain in the back area. Knighton can tolerate the doctor raising his right leg 35 degrees and his left leg 65 degrees from the table. Which leg can Knighton raise higher above the table? Using the angles given in the problem, you need to determine which leg can be risen higher above the table. Is it the left or right leg? Here's the diagram of the situation. Since Knighton's legs are the same length, and his left leg and the table is the same length in both situations, the Hinge theorem says his left leg can be risen higher, since 65 degrees is greater than 35 degrees. Therefore, Knighton can raise his left leg higher above the table. Example 4. Write an inequality to describe the possible values of x. Solution. In the figure, the length of the side opposite 50 degrees is x plus 2, while the length of the side opposite 48 degrees is 3. So, if 50 degrees is greater than 48 degrees, using Hinge theorem, x plus 2 is greater than 3. By addition property of inequality, add both sides by -2. We have x plus 2 plus -2 is greater than 3 plus -2. Simplify. X is greater than 1. Last example. Use the figure below. In triangle RST, side ST is opposite angle R, and side VW is opposite angle U. What is the relationship between ST and VW? Since angle R is greater than angle U, then ST is greater than VW. If ST equals 2x plus 1 and VW equals 9, write an inequality to describe the possible values of x. In triangle RST and triangle UVW, side RT is congruent to side UW. Side RS is congruent to side UV. And measure of angle R is greater than measure of angle U. Solution. Since 54 degrees is greater than 52 degrees, 2x plus 1 is greater than 9. Add both sides by -1, we have 2x plus 1 plus -1 is greater than 9 plus -1. 2x is greater than 8. Divide both sides by the numerical coefficient of x, which is 2, x is greater than 4. That's all for today. Thank you and goodbye. See you next time. Stay safe.